All right, so we're working on the midterm study guide for college algebra, and I'm going to do number 26 with you. Notice it is a quadratic because it's x squared and an inequality. To solve these, you start out just like a regular quadratic. You can actually just use it like a quadratic to get your boundary lines, but we'll come back to that inequality before we're done. So get it in standard form, and either by factoring or formula, get your two solutions. Let's see, to get 12, I know 4 times 3 multiplies to be 12 and adds to be 7. Then I set each part equal to 0 by the zero factor property, and then solve each part, giving me my two x solutions. If this were an equation, that's all we would report. That would be the answer. But since it's an inequality, it divides the number line into regions, and you have to test to see which regions are in the true regions. So you take your points that we found, put them on a number line, and notice that it cuts the number line at those. Those are just boundaries into region 1, the middle region 2, and the last region 3. And your job is to take test points and see which regions solve the inequality. I always like to check my 0 point. It's the easiest number to check. So find where you think 0 is on the number line. It's all the way over here to the right. And test that back in the original problem. 0 squared plus 7 times 0, is that less than or equal to negative 12 is the question. So again, our test point is 0 here, and that's a big 0. Is it less than or equal to negative 12? And it's not. So that region is not part of the solution. So I'm not going to shade it. Then I might check in here, like maybe negative 3.5, plug it in. And to save time, I'm going to say that works. It's kind of harder to check though because it's a fraction. And then check maybe here with negative 5. And it's always every other one. So if you're real careful on your first checking, it can kind of carry you. It's going to be every other one. So I'm kind of believing that one is the one that works, and then this one does not work. But let me just show you one more check. Negative 5 squared plus 7 times negative 5, is that less than negative 12? That's 25 minus 30, positive 25 because the negative is squared, minus 35 is negative 10. Is negative 10 less than or equal to negative 12? And it is not. It is not. That is actually a bigger number. So that is not true. I'm just going to say we check that one. That's the region that works. That's the region we shade. Everything between negative 4 and negative 3, which is actually an infinite amount of things, although fractional pieces, from here to there. If there is a line under that, we include our endpoints. When possible, you include the endpoints because of the line. So our answer is the region negative 4 to negative 3 in interval notation. Okay, let's do another one of those, number 20. Well, actually, I'm going to skip, well, yeah, let's do 27. 27, get another practice of that. It is a similar problem. It's again quadratic. It's a very similar quadratic, you can see, except it's got a negative in the middle. So when we factor it, it'll be x minus 4, x minus 3. To get our boundaries, that gives us boundaries of 4 and 3, and they're positive this time. So when we put those on the number line, it divides our number line at 3 and at 4. So we've got 3 different regions. So remember, you're checking the regions. I like to check where 0 is. 0 would be all the way over here on the left in this particular example. I checked that in the original problem. 0 squared minus 7 times 0 plus 12, is that greater than or equal to 0? So we have to decide yes or no on that. So that's all 0. 0 plus 12 is 12. And yeah, that is true. That is true. So where that testing point 0 was, I should shade all of the things in that region should also be true. Then I check in here, and then I check over here. This region does not work. You'd have to check a fraction like 3.5 on it. Doesn't work, then you check like maybe 5, 6, anything in this region, it works. So again, to save time, I'm just going to say we checked a test point. So it's 2 different regions, so we're going to have to use the union symbol. When the line is under this, we do use a bracket. So our solution will be this region is negative infinity to negative 3, bracket, union, plus this answer, 4 to infinity. Okay, let's do one more in this little section before we move on. Number 28, another type of inequality. So this is from 1.7, the inequality section. If you need to look that up in your book, see more examples. But on 28, we have a fraction or rational and an inequality. Step 1 is you have to be equal to 0. One consolidated fraction and a 0. So this one's ready to go. Consolidated one single fraction and then an inequality 0. Once it's set up like that, you set the numerator equal to 0, you set the denominator equal to 0, and that will give us our boundary lines like we had in our last problems. So you get two parts, x is 7, x is negative 8. Those are where it cuts the number line, critical values at negative 8 and positive 7. And then we're back to that, checking the regions again. That's kind of the name of this little section. You gotta check inside each region to see which one solves the original problem. So I like to check 0, and it's between negative 8 and 7 this time. Plug it into the original problem and see if it works. Is this true or not? 0 minus 7 over 0 plus 8 is the fraction negative 7/8. Is that less than or equal to 0? And it is, that's true. So where 0 is my test point, I should shade. Then you check something out here, it does not work. Maybe check something over here like 8, 9, 10, that also does not work. So it's always every other region, so it's either the middle part or the two outer parts, just to help you out there. So the middle part works this time. Now this one's a little tricky about the parentheses and brackets, and especially on a multiple choice test, excuse me, you want to be careful about the details. That's where they get you on a multiple choice test. You have to watch your details even closer, because you might just overlook this. But on the other problems, we didn't have to worry about it because they weren't fractions. But if there's a line under this inequality, that means to use a bracket normally. But we cannot bracket what makes the denominator equal 0. So this negative 8 cannot be included as a solution no matter what this says. So whatever makes the denominator equal 0, use a parenthesis. So negative 8 has a parenthesis, but the 7 that's from the numerator boundary, we do use a bracket. So it's got one of each actually on that for a real particular reason. The line under it, you should use a bracket if possible, but we have to exclude anything that makes the denominator equal 0. So our answer should look just like that. We'll stop it there.